Hi students, welcome to this section where we deal with factorials. Now what do we mean with factorials? Say you want to find out n factorial, that would be equal to 1 into 2 into 3 into 4 up to n. That's n factorial. So for example, if you want to find 4 factorial, that would be 1 into 2 into 3 into 4, which is equal to 24. Similarly, you can see that 5 factorial is 1 into 2 etc. up to into 5, that's equal to 120. Alright, now what are the different ways in which you can express factorials? You could write it as f of x plus 1 is equal to x plus 1 into f of x, right? And say it's given f of 1 is equal to 1. In that case, this is nothing but factorial. Let's try to take f of 3. F of 3 would be 3 into f of 2, right? And what is f of 2 as per this? It would be 2 into f of 1, and we know f of 1 is given as 1, so this is 3 into 2 into 1, which is nothing but 3 factorial. Alright, now can you think of any other scenario where we have used factorials? Yes, in permutation and combination, if you remember, if you want to arrange n things at n places, right, that's equal to npn, and that simplifies to n factorial, right? N factorial by n minus n factorial, which is equal to n factorial. Now we are not covering this in this section. This will be covered in the section on permutation and combination. Alright, now having established the basics of factorial, let's try to do a question. F of x plus 2 is equal to 20 into f of x, where f of x is equal to x into f of x minus 1. The question says find x. Pause the video, give it a try, and then let's do it together. Alright, as per this equation given over here, let me write f of x plus 2, right? That would be x plus 2 into f of x plus 1, right? Over here I just substitute x plus 2 instead of x, and then I will get, instead of x minus 1, I will get x plus 1 over here, right? So f of x plus 2 is equal to x plus 2 into f of x plus 1. Now over here, f of x plus 1, I can expand it using this formula as x plus 1 into f of x, right? And it is given that this will be equal to 20 times f of x, right? Why is that so? F of x plus 2 over here is given as 20 f of x. That's what we started with. Therefore, this expression over here is equal to 20 times f of x. Now let me cancel out f of x from the left hand side and the right hand side, and I am left with x plus 2 into x plus 1 is equal to 20. Now I know that 20 is equal to 5 into 4, right? 5 into 4 is equal to 20. So I can apply that over here. So that would be 5 into 4 is equal to 20. So why is that? The difference between x plus 2 and x plus 1 is 1, right? So if you write 20 as the product of two numbers whose difference is 1, that would be 5 into 4. Now if x plus 1 is equal to 4, I can say x is equal to 3, which is what is asked to find. So that's the answer, x is equal to 3. Hi students, let's discuss how to find the highest power of a prime number in a factorial. Alright, we have a demo question over here. Find the highest power of 5 in 100 factorial. Now we know 100 factorial is the same as 1 into 2 into 3 etc. into 100. Now we need to find the highest power of 5 that can perfectly divide 100 factorial, right? Or I can rewrite this question as 100 factorial divided by 5 to the power x gives me a remainder of 0. Find the highest value of x. That's the same question that we have over here. Alright, now let's see how we can do this type of questions. For this, let me write 100 over here, and I take out 5 from 100, that leaves me with 20. I take out 5 from 20, and that leaves me with 4. Alright, if I do this operation over here, the answer to the highest power of 5 in 100 factorial is 20 plus 4, which is equal to 24. Now you can see that this expression, this operation that we've done over here is the same as doing 100 by 5 plus 100 by 5 square plus 100 by 5 cube etc. 100 by 5 will give you 20, 100 by 5 square will give you 4, and anything above that 100 by 5 cube onwards is equal to 0, and therefore 20 plus 4 will give you 24. Now you need to notice that this is not the same as factorization, right? Let's take an example of what is the highest power of 3 in 100 factorial. Okay, highest power of 3 in 100 factorial. That would be done like this. You can see from 100 I take out 3, I write 33 over here. This is actually the quotient when you divide it. So 33 by 3, the quotient is 11. You disregard the remainder and you go ahead and continue dividing. So you get 11 over here. 11 by 3, your quotient is 3. Your remainder is 2. You ignore the 2. You keep the 3 over here. Again 3 by 3 will give you 1, and 1 by 3 will give you 0. So you can stop at this point. And over here the highest power of 3 in 100 factorial will be 33 plus 11 plus 3 plus 1. That's this 33 plus 11 plus 3 plus 1. So this is actually division, it's not factorization, right? We're just dividing and ignoring the remainder, and we keep on dividing. In this video, let's learn how to find the highest power of a composite number in a factorial. Earlier we have seen how to do it for a prime number. Over here we see how to approach it in case of a composite number. Alright, we have a question over here. Find the highest power of 10 in 100 factorial. The same question can be rewritten as find the number of zeros in the end of 100 factorial. Alright, now over here the composite number given is 10. Now 10 is equal to 2 into 5. So we need to write the given composite number as a product of prime numbers, right? And you can have, in case it's 4, you would have written it as 2 square into 5, right? In the case the question was for 20, you would have written 20 as 2 square into 5. Alright, so we prime factorize the given composite number. Now after doing this, let's find out how many 2's and how many 5's are there in 100 factorial. Let's start with 2. So 100 divided by 2 gives me 50. 50 divided by 2 gives me 25. 25 divided by 2 gives me a quotient of 12. Right? I ignore the remainder. 12 divided by 2 gives me a quotient of 6. 6 by 2 gives me a quotient of 3. 3 by 2 gives me a quotient of 1. Therefore, if I want to see the number of 2's in 100 factorial, that would be 50 plus 25 plus 12 plus 6 plus 3 plus 1, which is equal to 97. This is what we have seen even in the previous section, right? Now let's find how many 5's are there in 100 factorial, or what is the highest power of 5 that can perfectly divide 100 factorial. Alright, let's do 100 by 5. That gives me 20. 20 by 5 gives me 4, and I can stop there because 4 by 5 gives me a quotient of 0. Now 20 plus 4, that's 24. So we have seen that in the case of 100 factorial, how many 2's and how many 5's are there? We have seen that 97 2's are there and 24 5's are there. Now for 110, we need 1 2 and 1 5. So we need to group them, right? So as we have only 24 5's, we can only form 24 groups of 2's and 5's, right? Therefore the answer is 24. And in this method, we have seen how to find the highest power of a composite number in a factorial. Let's do this question. Find the highest power of 405 that can divide 285 factorial exactly. Alright, now the first step for this is factorize 405, right? Let's do that over here. So we can see that 405 can be written as 5 into 3 to the power 4. Alright, therefore to answer this question, and note 405 therefore is a composite number, right? You can see it's a composite number. So we have prime factorized it. Now to answer this question, we need to check in 285 factorial how many groups of 3 to the power 4 are there and how many 5's are there. And to make one 405, we need one group of 3 to the power 4 and 1 5, right? Alright, let's start. Let's see how many 3's are there in 285 factorial. So 285 divided by 3 gives me 95. 95 by 3 is 31. 31 by 3 is 10. 10 by 3 is 3 and 3 by 3 gives me 1. So I am only taking the quotients and I am going on dividing, right? Therefore 95 plus 31 plus 10 plus 3 plus 1, that's 143s in 285 factorial. Now we don't just need threes, we need groups of 4 threes, right? So that's 140 by 4, which is equal to 35. So I have 35 3 to the power 4s. So this over here is 35. Now let me see how many 5s I have, right? Now that would be 285 by 5 is 57. 57 by 5 is 11. 11 by 5 gives me 2. So 57 plus 11 plus 2, that's 70. So I can see I have 70 5s, right? That's 70 5s over here. Now I need to form groups of 3 to the power 4 and 5. Because I have only 35 groups of 3 to the power 4, I'll be able to make only 35 groups. Therefore my answer is 35. Or the highest power of 405 that can divide 285 factorial exactly is 35, or in other words 285 factorial divided by 405 to the power 35 will give me a remainder of 0. Hi students, so far we have learned how to find the number of zeros in the factorial of a given number. For example, we have seen that in 100 factorial, at the end of this number there will be 24 zeros, right? Now let's try to analyze questions of the reverse type. Say you are given that the factorial of the number has 24 zeros and we are asked to find what number's factorial was taken. Alright, let's go on. We know that the number of zeros at the end of a factorial depends on the number of 5s and the number of 2s, right? And we know that the number of 5s will be lesser than the number of 2s. Therefore, the number of zeros at the end depends on the number of 5s that we can take out from the factorial. Now, let's analyze this. Say you take the numbers from 5 factorial up to 9 factorial. That's 5 factorial, 6 factorial, 7 factorial, 8 factorial and 9 factorial. What's the highest power of 5 in these factorials? You will see that the highest power of 5 in these factorials is equal to 1. That means if you take 5 factorial, we know 5 factorial is equal to 120, and you will see that there is only 1 0 at the end of 5 factorial. Similarly, up to 9 factorial, at the end of the number there will be only 1 0. So 1 over here indicates that at the end there will be 1 0. Alright, let's move on. Say you take 10 factorial till 14 factorial. You can see that the highest power of 5 in these numbers is equal to 2. Therefore, at the end of say 10 factorial or 14 factorial, there will be 2 zeros. Now, in a similar manner, if you take 15 factorial to 19 factorial, the highest power of 5 in these numbers is 3. If you take 20 factorial to 24 factorial, the highest power of 5 in these numbers is 4. If you take 25 factorial to 29 factorial, remember over here it's 1, it's 2 over here, it's 3 over here, it's 4 over here. We might feel to write 5 over here, but in the numbers 25 factorial to 29 factorial, the number of 5s or the highest power of 5 is 6. It's not 5, it's 6. So we can see that from 4 to 6 there is a jump of 2. That's because 25 is equal to 5 square. Alright. So let's see that. For example, if I take 25 factorial, we have seen how to find out how many 5s can be taken out of it. So I write 25 over here. It goes 5 times. I get 5 over here. And 5 by 5 gives me 1. So 5 plus 1 is 6. Now let me take 24 over here. If I take 24 by 5, it goes 4 times. And 4 I cannot further divide. So that's 4 over here. So you can see 20 factorial to 24 factorial has 4 zeros. 25 factorial to 29 factorial will have 6 zeros. Now remember, there will always be only 5 numbers with a given number of zeros. So there are 5 numbers, that's 5, 6, 7, 8 and 9, whose factorial will have 1 0 at the end. Similarly, 25, 26, 27, 28, 29. There are 5 numbers whose factorial will have 6 zeros at the end. Let's do this question. How many natural numbers are there such that their factorial is ending with 5 zeros? Alright, we have seen that it's always 5 numbers. So the answer can only be either 0 or 5, right? Now, we have already seen that in the case of 5 factorial to 9 factorial, it's 1 0. In the case of 10 factorial to 14 factorial, it's 2 zeros. 15 factorial to 19 factorial, it's 3 zeros. 20 factorial to 24 factorial, it's 4 zeros. And 25 factorial to 29 factorial, it's 6 zeros, right? There is a jump of 2. So the answer over here is 0. There is no number. There's no natural number. If you take the factorial of that number, you get 5 zeros at the end. There is no such number. Either it will be 4 zeros or 6 zeros. And there is a jump of 2 over here because we have 25 factorial over here. You can note that similarly, when you get to 125 factorial, there will be a jump of 3 zeros, right? The numbers, if you compare 124 factorial and 125 factorial, there will be an increase of 3 zeros. Let's quickly see that. Let me do 125 by 5. That gives me 25. 25 by 5 gives me 5. And 5 by 5 gives me 1. So that's 25 plus 5 plus 1. That's 31 zeros in the case of 125 factorial. Now let me do 124 factorial. I divided with 5. That goes 24 times. Now 24 divided by 5. It goes 4 times and it stops over there. So that's 24 plus 4. That is 28 zeros. So you can see from 28 to 31 there is an increase of 3 zeros. Let's do this question. If n factorial and 5n factorial end with 25 zeros and 133 zeros respectively, then which of the following is a factor of n? So we are asked to find a factor of n. Alright, pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Over here we can see the given factors are 25, 26, 27, 28. And we need to choose one of these 4 options. Now, we know that 100 factorial ends with 24 zeros, right? We have seen that already. So the number of zeros we have seen depends on the number of 5s that you can take out. The highest power of 5 in 100 factorial can be found like this. 100 by 5 gives you 20, 20 by 5 gives you 4, and you cannot go any further. So 20 plus 4 is 24. That's why in 100 factorial, it will end with 24 zeros. Alright, now over here it's mentioned 25 zeros, right? So we just need to take the next set of numbers. We know 100 to 104 will have 100 factorial to 104 factorial will have 24 zeros. So in this case, n factorial has 25 zeros. So based on this, n can be 105, 106, 107, 108 or 109. Alright, all of these will end with 25 zeros. Alright, now let's try to factorize each of these because we have options. The good way of solving this is using the options. So 105 can be factorized as 21 into 5. Similarly, 106 is 53 into 2. 107 is a prime number. 108 is 27 into 4, right? And 109 is a prime number. Now let's use the options. You can see that over here you have 27. So your answer is 27 because for 108 that's 27 into 4, right? There is no other number over here that we can get from these factors. That is, none of these have 25 as a factor, none of these have 26 as a factor, and none of these have 28 as a factor. So the only correct answer can be 27.